In the name of Almighty God, the most compassionate and the most merciful, I welcome you all, my lovely brothers and sisters, to your own channel. By the way, it is our second lecture on chapter 3 of Trigonometry. In 3.1, we have proved the sum and difference of the angles. By the way, today we will talk and we will have our best examples related to the sum and difference of the angles. And obviously, our first example would be easy, and step by step we will have our most interesting examples related to this chapter. By the way, the first example is, what is sine 75 degree? We have studied sine of alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. If this is negative, so in here our sign is negative. We proved cosine of alpha plus beta, which the relation is cosine alpha cosine beta minus sine alpha sine beta. If this one is negative, this is positive. Am I right or not? Yes. And also we have proved tangent alpha plus beta, which is tangent alpha plus tangent beta divided by 1 minus tangent alpha times tangent beta. If this is negative, our numerator is negative and denominator is positive. I think we have proved. Now, whenever you want to find 75 degree, the trigonometric ratios, you have to think that which standard degrees or which degree that you know the summation or difference is 75. I think the 75 can be defined as 60 plus 50, 45 plus 30, and 50 plus 25, and many more. But in here, we know the relations and the trigonometric ratios of 60 degree, but we don't know the 50 degree. So, it is not correct to choose the first option. Whenever you're talking about 50 and 25, you don't know the trigonometric ratios of 50 degree and also 25 degree. So it is not correct. But whenever you want to talk about 45 and 30, you know the relations, the trigonometric ratios of the 45 and 30 degree. So you have to choose, instead of 25, alpha plus beta, which is what? Which is 45 with 30 degree. I mean that this sine 25 is equal to sine 45 plus 30 degree. Am I right or no? Yes. Now, this one is our alpha and this one is our beta. So, the formula looks like 45 degree plus 30 degree. Now, if this one is alpha and this one is beta, sine alpha plus beta, the first relation, I think, sine alpha cosine beta plus cosine alpha sine beta. Sine alpha, alpha is 45, times cosine beta, beta is 30 degree, plus cosine alpha, alpha is what? 45 degree, and sine beta, which is 30 degree. Now, you know, what do you know? What is sine 45? It is 1 by root 2. Am I right or not? Or root 2 by 2. Simple. And what is cosine 30? I think this one. Plus, in here, this one is 1 by root 2. And sine 30 is 1 by 2. Now, it is, you can simplify, 2 root 2 plus 1 2 root 2. Now, what do you have the factors in denominator? 2 root 2. And our numerator is root 3 plus 1. This is what? This is the sine 45 plus 30, which is what? Sine 25. Now, sine 25 degree is root 3 plus 1 by 2 root 3. I think you have got. Now, like this one, you can define cosine 75 also. Also, you can define tangent 75. Also, you are able to define sine 15 degree, cosine 15 degree, and tangent 15 degree. If I want to talk about 15 degree, what are the difference or sums of the angle which is 15? I think 45 minus 30, or 60 minus 45. 60 minus 45 is also correct. You know the trigonometric ratios of 60 degrees and also 45 degrees, and the 45 minus 30 is also correct. You know all the trigonometric ratios of 45 degree and 30 degree. Both gives similar answer. Write it please. We will proceed. Question number 2. Sine x plus y multiplied by sine x minus y is equal to sine square of x minus sine square of y. You have to prove this one. By the way, I will write once again sine x plus y multiplied by sine x minus y. Now, listen to me. This one is alpha, this one is beta. What does it look? It looks like sine alpha plus beta. Now, you know the formula of sine alpha plus beta. What is the formula? Sine alpha cosine beta plus cosine alpha sine beta. Am I right or not? Yes. Now, this is in multiplication with this, with the second term. Now, this one is also alpha, this is beta. Sine alpha minus beta. I think sine alpha times cosine beta minus cosine alpha, which is x, sine beta, which is 1. Now in here, look, this one is A, this one is also A, this is B, this is B. A plus B multiplied by A minus B. It is A square minus B square. Am I right or not? A square, which is sine x cosine y, whole square, minus b square, which is cosine x sine y, whole square. Now, this 2 belongs to both of them. It is sine square of x cosine square of y minus cosine square of x sine square of y. Now, we have found this one, but we have to prove that it should be sine square of x minus sine square of y. What does it mean? It means we have to prove that the answer should be in terms of sine, not cosine. So instead of cosine, I will write the sine term. What that one is? It is 1 minus sine square. Am I right? Yes. Instead of cosine square, can I write 1 minus sine square of x? Our angle is x, and here our angle is y, times sine square of y. Now in here, sine square of x times 1, it is sine square x, minus sine square of x, sine square of y, minus this minus multiplied by 1, minus 1 multiplied by this one, minus sine square of y, minus plus this one, plus sine square of x, sine square of y. I think this is cancelled. Yes, sine square x minus sine square of y, sine square of x minus sine square of y. Write it please. Question number 3. Tangent 3x minus tangent 2x minus tangent 1x is equal to tangent x times tangent 2x times tangent 3x. N includes integer number and x does not include n pi divided by 2y, because maybe if I put an integer number, for example 1, 2, 3, 4, 5, for example if I put 1, so in here one of these terms will not be defined. Am I right? Or maybe 2 terms or 3 terms. For example 1 pi by 2, it's pi by 2, tangent pi by 2 is infinity. It's not defined. By the way, how we have to prove that both of them have similar meaning? In here, I will write tangent 3x, once again the question, minus tangent 2x minus tangent 1x is equal to tangent x times tangent 2x and tangent 3x. I would put this one to the left side and I would put this one to the right side. Why? Listen to me. Tangent 3x, this plus comes negative, tangent x, tangent 2x, am I right? Tangent 3x. Now in here, this one is tangent x and 2x, tangent x plus tangent 2x. Am I right? Yes. Now we have as a factor tangent 3x. So tangent 3x is as a factor we have taken. Tangent 3x by tangent 3x, it's 1 minus tangent x times tangent 2x. Am I right? Yes or no? Yes. Yes, it's completely right. Now in here, what do we have? Tangent x plus tangent 2x. Tangent x plus tangent 2x. Now, I will divide both sides by this one. So, tangent 3x is equal to tangent x plus tangent 2x divided by 1 minus tangent x times tangent 2x. Now listen to me. Listen carefully. If this one is alpha, this one is also alpha. If this one is beta, this one is beta. So tangent alpha plus tangent beta divided by 1 minus tangent alpha times tangent beta. So what do you think? This is the formula. This is the formula, tangent alpha plus tangent beta, 1 minus tangent alpha times tangent beta, tangent of alpha plus beta. So our right side is tangent of alpha. What's alpha? It's x. And what's beta? It's 2x. What do you have in the left side? It is tangent 3x. Now listen to me. Tangent 3x, put this one as it is. Now x plus 2x, it is 3x. It means both sides are same. So the left side is proved to be as the right side. Write it please. Question number 4. A is equal to tangent 25 plus tangent 20 plus tangent 25 times tangent 20. Now what this A is? It means after simplification all the values of these trigonometric ratios, what is the value of A? Very simple. If I want to define tangent 25 plus 20, why I choose this one? Because our A is with the numbers of 25 and 20. It is consisted from 25 and 20. So I define 25 and 20. Why do I define the tangent? Because it is in terms of tangent. So this is alpha, this is beta. Now what do you think? Tangent alpha plus tangent beta divided by 1 minus tangent alpha, which is 25, tangent beta, which is 20. Now 25 plus 20, I think it is 45, is equal to, it is in terms of degree. If I do not write this one, then I am sorry. It is all in terms of degree. Am I right? Yes. Now, what is the value of tangent 45? It is 1 equal to tangent 25 plus tangent 20 divided by 1 minus tangent 25 times tangent 20. If I have a cross multiplication in this equation, so 1 times this one, it is tangent 25 plus tangent 20 and 1 times this one, it is 1 minus tangent 25 times tangent 20. If I put this one in the left side, So what do you think? It is tangent 25 degree plus tangent 20 degree plus tangent 25 degree times tangent 20 degree is equal to 1. Now this one is A. Am I right? Yes. A is what? 1. Write it please. Question number 5. B is tangent 77 minus tangent 17 minus root 3 tangent 27 times tangent 17. What B is? It is same like question number 4. What do I mean? It means the relation of 77 with 17. So if I define tangent 77 minus 17, or if I define tangent 77 plus 17, from which relation you think it will be correct? I think the first one. Why? Because 77 minus 17, it is tangent 60 that we know. But 77 with the 17, I think it would be tangent 94 degree that we don't know. So in here, I will define our first relation. I mean tangent 77 minus 17. Now, if this one is alpha and this one is beta, tangent alpha minus beta, I think tangent alpha minus tangent beta, am I right? Divided by 1 plus tangent alpha times tangent beta. Now, 77 minus 17. 77 minus 17, it is 60. What is tangent 60? Tangent 60 is root 3. This is the value for this one. Now we have in the right side tangent 77 minus tangent 17, 1 plus tangent 77 times tangent 17. Now, what do you have in denominator? 1. 1 multiplied by this one, it is tangent 77 minus tangent 17. And root 3 multiplied by this one, it is root 3 plus root 3 tangent 77 degree times tangent 17 degree. If I put this side in the left side, you would have tangent 77 minus tangent 17 degree minus root 3 tangent 77 times tangent 17. And what do you have in the right side? You have root 3. Now, what do you think this one is? It is our question. Our question is B. So B is root 3. Write it please. Question number 6, a very tricky questions we have. Tangent 36, tangent 72, tangent 72, tangent 108 plus tangent 108 multiplied by tangent 144 plus 3. Now what A is? After simplification, what our value for A is? Very simple. Can I write this one? A is equal to instead of tangent 36, tangent 72, instead of 3, I can write 1 plus tangent 36 degree times tangent 72 degree plus 1 plus tangent 72 tangent 108 and plus 1 plus tangent 108 degree times tangent 144. Now listen, this 1, 1, it is 3. Tangent 36, 72, this one is this, and this one is that one. Am I right? Yes. Now, here, listen to me. I will write this one in bracket. This one also. Am I right? Now in here, what do you think? 1 plus tangent alpha times tangent beta. There is something like this one. It means if I define tangent 72 minus 36 degree. 72 minus 36 degree. Why I define 72 minus 36 degree? Why I do not define 72 plus 36? Listen to me. You will, I'm sure, you will observe it. This is alpha, this is beta, so it is tangent alpha minus tangent beta divided by 1 plus tangent alpha times tangent beta. Because of denominator, I defined this one. But why? Because if I define 72 minus 36, we will have 1 plus tangent alpha tangent beta. And here we have 1 plus tangent alpha tangent beta. So this denominator, it looks like this one. For this result, I define the what? The negative one, the difference. And here, can I change the position of this one with the denominator? Yes. So you will have 1 plus tangent 72 times tangent 36 degree is equal to tangent 72 minus tangent 36 divided by tangent 72 minus 36. 72 minus 36, which is tangent 72 minus 36. I think it is 36. Yes. All of them are in terms of degree. This is our first equation. Am I right? Yes. Now, here, listen to me. For this one, I will define tangent 108 minus 72. I think you have got that why I defined 108 minus 72. So, what is the formula? Tangent alpha minus beta. It is tangent alpha minus tangent beta divided by 1 plus tangent alpha times tangent beta. Can I change the position of this one? Yes. 1 plus tangent 108 times tangent 72 is equal to tangent 108 minus tangent 72 divided by 108 minus 72. What this one is? I think 36. This is our second equation. Correct? Yes? Okay. Now, for this one, I will define what? 144 minus 108. Yes. Tangent 144 minus 108. Now, what the relation is? Tangent what? 144 minus tangent 108, 1 plus tangent 144 times tangent 108. Can I change the position of this denominator with this one? Yes. 1 plus tangent 144 times tangent 108 is equal to tangent 144 minus tangent 108 divided by 144 minus 108. I think it's once again 36. This is our third equation. Now, what do you think? We have first equation, second equation, and third equation. I want to add all these three equations. Equation number 1, number 2, and number 3. So, this one, 1 plus this one, 1 in left side, 1 plus tangent 72 times tangent 36 plus second equation, left side, 1 plus tangent 108 tangent 72. Third equation, 1 plus tangent 144 times tangent 108. Am I right? Yes. This one, tangent 72 minus tangent 36 divided by tangent 36 plus this one, tangent 108 minus tangent 72 by tangent 36. This is tangent, I'm sorry, tangent 36. 108 minus 72 is 36, tangent 36. Okay, the next one, tangent 144 tangent 108 divided by tangent 36. Is it correct? Yes. Now, what this one is? This one. And this one is A. This one. A. 1, 1, 1. It is 3. Tangent 36, 72 or 72, 36. We can change the position. This one is our second term. This one is our third term. So, this is our A. Now, in here we have tangent 36 as a factor in denominator. Now, what do you have in numerator and numerator? Tangent 72 minus tangent 36 plus tangent 108 minus tangent 72 plus tangent 144 minus tangent 108. Now, in here, this is cancelled. Am I right? Yes. This is cancelled. Yeah. So, what do we have? A is minus tangent 36 plus, instead of this one, instead of 144 degrees, can I write tangent pi, which is 180 minus 36? Yes, pi 180 minus 36, it is 144 divided by tangent 36. Now, our B is minus tangent 36, put this one as it is, plus, now tangent pi minus 36, it is tangent 36. In which quadrant? In second quadrant. In second quadrant, tangent is negative. So this is negative. Am I right? Yes. Divided by tangent 36. So this one is B is equal to minus tangent 36 minus tangent 36. It is minus 2 tangent 36 divided by tangent 36. So this is cancelled. Our answer is B is minus 2. Write it, please. Question number 7. Tangent A plus tangent B plus tangent C is equal to tangent A times tangent B tangent C. You have to prove if A, B and C are the internal angles of a triangle. What do we know? We know one thing, that if we have ABC, the inside angle or internal angle of a triangle, so the addition of all these three angles, it should be 180. Am I right? Yes, it should be 180 degree. So A plus B, can I write this one is pi minus C? Yes. I will take both sides tangent. It means I will calculate the tangent of the left side and tangent of the right side. Now, what does it look like? I think it looks like alpha plus beta. So this one is tangent alpha plus tangent beta divided by 1 minus tangent alpha, which is A, and times tangent beta, which is B. Now, tangent pi minus C, it is tangent C. In which quadrant? Second quadrant. 180 minus something, it is second quadrant. 180, which is pi, minus something, it is in second quadrant. In second quadrant, tangent is negative. Am I right? Yes. It was very simple. Very. Now, in here, I want to have cross multiplication on both sides. So 1 times this one, it is tangent A plus tangent B. Now this one is multiplied with this one, minus tangent C, minus with this minus is plus tangent A times tangent B times tangent C. Now I will put this one in the left side. So what would you have? Tangent A tangent B plus tangent C is equal to tangent A times tangent B and times tangent C. I think it is proved. Write it, please. Question number 8. Tangent x divided by cosine 2x plus tangent 2x divided by cosine char x plus tangent char x divided by cosine 8x is equal to tangent 8x minus tangent x. You have to prove the left side should be like the right side. Now what we can do? One thing what we know is if we have a mix of the trigonometric ratios, please change all them to sine and cosine. It would be easy. I mean, instead of tangent x, can I write this one sine x divided by cosine x? Yes, times cosine 2x. Plus, in here, sine 2x divided by cosine 2x multiplied by cosine 4x. Plus, here, sine 4x divided by cosine 4x multiplied with this one cosine 8x. Am I right? Yes. Now what do you think? So we have to think about the when we change all the trigonometric ratios in terms of sine and cosine. The second term that you have to do is please focus on the angle. The angles should be same, or we should find a relation between the angles. In here we have x, we have 2x, we have 2x, we have 4x. This 2x was the same tangent. We have 4x and 8x. So I want to write, instead of sine x, can I write sine 2x minus x? Yes. So why I did it? Wait a moment. You will find cosine x, cosine 2x, plus in here, instead of this one, can I write sine 4x minus 2x? Yes, we can. And also in here, can I write sine 8x minus 4x? Yes. We did for this one, the 2x minus x, we have 2x in here, we have x. We have 4x and 2x, 2x and 4x. We have 8x and 4x, 4x and 8x. So I defined a relation between the angles. Now this one looks like sine alpha minus beta. Sine alpha minus beta, I think this is sine cosine minus cosine sine. Am I right? Yes. Sine 2x cosine x minus cosine 2x sine x divided by this one. Plus here also alpha minus beta, sine 4x cosine 2x minus cosine 4x times sine 2x divided by this one. Plus here sine alpha minus beta, sine 8x cosine 4x minus cosine 8x times sine 4x divided by cosine 4x cosine 8x. Now look, can I define this divided by this one and this divided by this one individually? Yes, we can do, according to polynomial divided by a monomial. So if I divide this one by this one, so cosine by cosine is cancelled, sine by cosine, this is tangent to x, minus this one divided by this one, cosine with cosine, this is cancelled, sine by cosine, it is tangent x. Am I right? Yes. Here division of a polynomial by a monom. So if I divide this one by this one, so we will have a cancel of cosine, sine by cosine, this is tangent. Right? Yes, minus. And if I divide this one by this one, so we will have a cancellation of cosine, and the remaining is sine divided by cosine, which is tangent. Plus this one also, cosine with cosine is cancelled, sine by cosine, it is tangent. Minus this one by this one, cosine is cancelled, sine by cosine, it is tangent. Now, if I remove the brackets, what would we have? We have tangent 2x minus tangent x plus tangent 4x minus tangent 2x. Am I right? Yes. Plus tangent 8x minus tangent 4x. Now, this tangent 2x with this tangent 2x is cancelled. Right? Yes. Tangent 4x with tangent 4x cancel. What is our remaining part? Our remaining part is tangent 8x minus tangent x. Hence, it is proved. Write it, please. By the way, it is all our lecture 3.2. We will have in 3.3 our next very interesting and tricky questions on this chapter, inshallah. By the way, may Allah save you. Allah Hafiz.